I'm a big fan of this question. Here we go. I'm going to draw a diagram to start with, and I'm going to say the dimensions of my container are x, y, and z. Now we're told it is partially filled and the volume is 120. So the depth is either 2, 3, or 5. So in this case, I'm going to say it's 5. Yeah, it doesn't matter if, I've just chosen x, y, and z to be certain dimensions, but it's not what we're ultimately interested in. So here it's going to be 5 times x times y, that's the volume, and that's going to be 120. Okay, let's turn the box around to a different orientation, and I'm going to say that now x is here, and this is y, and this is z. Right, let's say the depth now is 3. Okay, so from this it must be that 3yz is 120. And finally, I don't actually know if I've drawn it accurately when I've changed the orientation. I'm just changing it slightly, but right now it's going to be X and Z along here, and then Y up here. We've got a final one of 2. So it must be that 2xz is 120. All right, so what I see is that it must be that 5, because they're all 120, it must be that 5xy is equal to 3yz. Okay, I can go straight to that. I've technically got 3 simultaneous equations here, but I can just set those to equal, and then I can cancel out the y's, which means that x must equal 3/5 of z. Okay, so I'm now going to put that into this one here. I'm going to get 2 times 3/5 of z times z, so that's going to become z squared, is 120. So that means z squared is going to be 120 times 5 over 3 times 2. 120 divided by 6 is 20. 20 times 5 is 100. So z squared is 100. And that means z is going to be 10. And from that, I can get all the others. So x is going to divide by 5 to get 2. And then 2 times 3, I'm going to get 6. X must equal 6. And then for y, where should I put it back in? What's the best thing to do? Maybe this one. So here I've got 5x is going to be 30. 120 divided by 30 is going to be 4. So y is 4. And therefore the volume is going to be 10 times 6 times 4, or 24 times 10, or 240 meters cubed. Nice one.